SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 30, we will cover residential location choice model using multinomial logistic regression. So, the different concepts that would be covered in this lecture is residential location choice model using multinomial logistic regression and SPSS, and also we will do the same for using Python. So, residential location choice model, first we will start with SPSS. The present model is based on a survey that we carried out for Bidhannagar Municipal Corporation in West Bengal and New Town. This is also in West Bengal. So, these are two municipal areas which are near to the city of Kolkata, which is just adjacent to the city of Kolkata. The study was intended to understand the location choice behavior of households. Initially, few assumptions have been considered for the formulation of this particular model. Like for example, the household head is considered to be the decision maker and level of aggregation is considered at the ward level. So, initially we started at the ward level, but based on the model results, we found that ward level probably is not a good determinant for developing this kind of model because it was too small a choice. Instead, when we developed the area into 4 broad location choices based on the continuity as well as area characteristics and the development potential of this particular areas. Then 42 wards and 2 action areas from 42 wards from Bidhannagar Municipal Corporation and 2 action areas from Newtown were combined into 4 broad location choices. So, this is just for example. We also have developed a model for at the ward level model, but for explanation purposes, this 4 broad location choice model is a better alternative. So, here you can see the map of India. So, you see West Bengal over here, and then within West Bengal, this is the area that we are talking about, and this is the city of Kolkata over here. Like this part is Kolkata. So, this is Salt Lake adjacent to Kolkata. This is Bidhannagar Municipal Corporation. It looks like this, and then this is the New Town area. So, these are upcoming areas or developed areas which are being developed. So, this is the shape of the area that we are talking about. So, this is New Town, this is Salt Lake, old Salt Lake. This entire area is Bidhannagar Municipal Corporation, but this is the Salt Lake city. This is very developed area, and this area is newly developing this side, and this area is traditionally developed, means these are old areas which are already developed. This area is already developed, but these are very planned and a high-end development area of HIGs mostly. This area is mostly for MIGs and all, and this area is newly upcoming development, and this area is Newtown is also newly upcoming development, but mostly HIG kind of development. So, that's why we have divided into 4 broad categories, and we were trying to ascertain people who are deciding to move in this particular area, where they are going to locate themselves. They may locate outside, that was not our concern. If they were locating inside this particular area, we are trying to decide which is the broad zone they are going to settle in. So, that was our primary goal. We first tried to do it at the ward level. As you can see, these are the ward levels. There were 42 wards, but the model, that's a different model. But here for explanation, I am using a model where we have 4 broad zone categories. So, these are the variables that we have considered. We considered the religion, we considered monthly income, we consider these are all nominal variables, as you can see, LIG1, MIG2, HIG3, these are the 3 categories, and then number of members, age of household, marital status of household, and gender of household. These are again nominal categories, education of household head, occupation of household head, then family type, number of children, number of workers, these are continuous variables, then housing type, Ownership type, these are again nominal variables. Person, origin, migrants, car ownership, same as the last model almost. So median rent of location, median cost of location, walk travel time, proximity to public transport, proximity to school, residential area percentage, commercial area percentage, and location choice. So location choice we have categorized into 4 location choices: location A, B, C, and D. So these are the 4 categories. So now we can see that this is a multi-class problem. So we have to divide our prediction for these 4 classes, and there are around 22 independent variables which could be further broadly classified into socioeconomic characteristics, housing characteristics, and location characteristics. So as we are discussing that certain things like people of certain religions, we could hypothesize that they may concentrate to stay in a certain zone. It may not be true, but that is what has been tested. Or car ownership levels, a lot of these socioeconomic characteristics of the household, does it influence the location choice? People having more car may choose to live in a certain area, and so on. So we tested around 22 variables. So we first, this is the SPSS. We have already explained in our previous lectures. We have explained the software SPSS. You can install it, and this is the when you first load the data file, this is the view. You see the list of parameters over here, and these are the variables. And then you can also go to the data view, and once you click the data view, you then need to go to analyze in the menu bar. And then once you have, and then you can see the data over here. This is the total data. These are all gender data, then marital status data. And then once you go to analyze, you can go to regression. You can choose the multinomial logistic regression. And once you do that, the same window that we have seen last time, almost same, this will pop up. And this side you see all the variables that are available to us, and over here we have to choose the dependent variable, and here we have to choose the factors and the covariates. So next we will add the dependent variables in the dependent box. So here it is location choice. Next we have to set a default category. So it could be the first or the last category, because whenever we are predicting a choice, it is based on another category. So always it's the existing, so its choices are based on a reference to another choice. And then we need to include the different covariates, which are proximity, walk, travel time, medians, and also the factors like housing type. And then these are we need to on the classification tables, goodness of fit, all the statistics that are there. And once we have done that, then we can run the model, and this is the results that we are going to get. So goodness of fit, classification, and all these things we have entered. We can also include this independent variables as dummy variables, so that also goes into this covariate box. So this is the final results. So to interpret the results, first the results gives the case processing summary, and here so many cases have been processed, and then the model fitting information is given, where the table compares the full model with the explanatory variables with the null model without the explanatory variables by likelihood and chi-square test. So this explanatory variables is the null variable. The null model is basically the model with constants, and so we see that in the constant only model, this is the value of log likelihood. In the final model, this is the value, and we can say that the final model is significant by checking the chi-square value. So the present model, the statistical significance value tells that the final model is statistically significant improvement in fit over the null model, and this p-value is shown as lesser than 0. And then we look into the goodness of fit table, which gives information if the final model is a good fit to data or not. And here we see that the Pearson and deviance chi-square value is also within the tolerance limit, and p-value is less than 1. So this is the first initial statistics. Then we check the R-square statistics. These are pseudo R-square values. where we see that all variables are around 0.743 Cox and Snell, Nagarkar K is 0.797, McFadden is 0.504. So these are the R-square statistics, which gives us an idea about that how good the model is. And then the likelihood ratio test actually tells us the contribution of each independent variable to the model. That means the relative weightages of each independent variable to the model. And all the independent variables included in the model are significant predictors in the model with p-value greater than 0.5 are only included in the model. The ones which are not been included in the model. And finally, this is the format of the model. So these are the variables: intercept, edge. These are the individual, these are the household characteristics, and then these are some of the variables which are actually significant, which actually plays a role in the location choice. And this is the log likelihood value. This actually shows us the contribution of each of these particular variables to the overall model fit, overall model on the final model. So this actually shows us the relative importance of each of these factors. This is the classification table is next presented, which contains the model prediction accuracy for each category of dependent variables. So we can see that for the first category it's around 66%, then 61%, and so on. So and then for fourth category it is 85%. So overall fit is around 70% of the predictions are correct. So this is the parameter estimates. So over here you can see the location choices for each location, that is location choice for 1, 2, 3 and so on. The reference category is 4. So location choice of 1 compared to 4, location choice of 2 compare. So location choice of alternative 1 compared to alternative 4. So every time we predict the probability of one alternative, it is in reference to another alternative, and all the individual independent variables are in respect to that. So that means when we talk about proximity or walk travel time, this is one alternative 1 in reference to alternative 4. This is a walk travel time is negatively related. So when walk travel time reduces, the chance to choose this location increases. So that is how we should interpret. And we have also, along with the beta estimates, we also get the significance values for each of these parameters, and from here we can decide to keep them in the model or not. And but if we give a initial criteria that only more parameters which are more than 0.5 are included, then only the ones which would be meeting that criteria would be shown in the model. So it is so the MNL model estimates k minus 1 model, where k is the number of categories in the dependent variable. The present model compares location A, B, C choice against location D, which is the reference category, and the model is interpreted like the parameter estimates are relative to a reference category. That means for unit change in the independent variable, the logit of location A, B, C relative to the location of D is likely to change by its respective parameter estimate, given other independent variables in the model are constant. So that is being shown over here, where log of probability of location A divided by log of probability of location B is given by this particular utility function that is being developed over here for each of these models. And if I after keeping everything constant, if I change one value, so it will give me this particular change of location, probability of location A in compared to change in location D, what would be the change in probability that could be estimated. So this is how the MNL model has to be interpreted. But I will again reiterate that here all the choices have been, there are only 4 choices. So all the 4 choices have been estimated. So now suppose there were 1000 choices, you could understand we would have thousands alternatives, like 3, 4, 5, it will go on to 1000. So in that case we have lots and lots of model. So usually we don't do a interpretation using SPSS. So SPSS has limited capabilities in this way. So we in that case we use models like LIMDEP, other softwares like LIMDEP, and we use comments within LIMDEP to do this kind of estimation, and also we can use Python. So next, when we use Python, this is how it looks like. So you remember our discussion on the basic syntax for Python. from the last lecture. And here also we need to import the libraries at the beginning. So, you know, the pandas libraries is included for data manipulation and analysis. The sklearn or linear model is included. This is the machine learning library where we can also do we can run several statistical models, regression models. And this we first have to import the data set. This is where we read the CSV file from the location. This is the data file, and next we have to detail out the data frame. That is the we have to specify which are the parameters, like what are the x parameters and y parameters, what are the independent variables x and the dependent variable y, and that is what, and their locations in that particular data set is being provided over here. And then we call the logistic regression function, where we first feed the model, and we first define the variables and assign the logistic regression models for x and y, that set that we have earlier determined, have set. So x values and y values, we have said what are independent variables and what are dependent variables. Now we have to include them in the model, and accordingly we can print once we run the model over here, like we determine the model fit, we then can print the coefficients, we can print the intercept, we can print the R-square. So that is what is shown over here. We have print the coefficients of the model. This is for each location it will print. Here there is no reference category. This does the estimation in a different way. So for each location we have a utility equation, and using the same formula that we have used earlier, that is probability of a choice of a particular location is depended on e to the power utility of the location divided by summation of e to the power utility of all locations. So that is the formula that you have to use over here, and here you get the utility equations for each of the locations. For this is all the coefficients are given for the variables. So the first is intercept, and then the age, then housing type, then median rent, walk travel time, and proximity. And we can get the proximity values like 0.148, -042. So we can also interpret the signs and check if those are consistent or not. For location A, this is how this has come, location B and C and D and so on. So this is how we can use Python to also determine or develop our logistic regression model or multinomial logistic regression model. So we can see the print R-square values, which is 0.7, which is a pretty good fit, and we can print the results in this particular way. So these are references that you can consider. To conclude, residential location choice model has been developed using multinomial logistic regression in this example, and SPSS statistical software and Python programming language both has been used to develop this model. Result can be interpreted as per the reporting format in each case. Thank you.